Hi everyone. First of all, thank you for coming to the second week of riots at St. Thomas's. It's amazing to see so many new faces here interested in open science. My name is Alexandra, and I'm a third year PhD student in the Department of Perinatal Imaging and Health. I'm going to be speaking for the first half an hour, followed by Miguel. I think it's only important to start with a disclaimer and say that I'm not an open science expert. There may be a lot of people in the room who know a lot more than I do. But I'm here because I think that as early career researchers, it's easy to feel like these big problems that we hear about in science, with scary titles like the reproducibility crisis, don't really concern us. We can sometimes feel like there's nothing we can do, that these issues should be fixed by funders, by universities, by PIs, but not by us. So today, I want to focus on small ways that we can all incorporate open science practices into our workflow. So, if there's any message I want you to take away from today, it's that open science is not all or nothing. There may be things that are not feasible for our work, but always think about the fact that doing something is better than doing nothing, and incremental progress is still progress. Because open science is an umbrella term covering so many different aspects, and we all have heard about terms like open access or open code, open data, etc. Hopefully, there'll be at least something in my talk that applies to your work. So, why should we care about open science? Well, obviously, working reproducibly is the right thing to do, is the foundation of science. It's the honorable thing to do, and the world would be a better place if everyone did it. Well, I think we all know we wouldn't do it unless we had something to gain from it. So, we can also think about how open science can further our careers and what reproducibility can do for us. Well, Florian Markovets from Cambridge wrote a great paper called Five Reasons to Work Reproducibly. And some of the things that he lists are the fact that it helps avoid disaster, like losing your lab notes. It helps with writing papers because you have easily accessible code and data. It can help reviewers see it your way because they can run the code themselves. Enables continuity. Always think about the first reuser of your data being your future self. And it helps build your reputation as an open scientist. Maybe it's also encouraging to think that while early career researchers are pushing for change from the bottom up, there are also several initiatives happening at a higher level. So, kind of pushing top down for change. One of them is the UK Reproducibility Network that is currently working with universities, journals, and funders to develop open science initiatives throughout the UK. So, just in case I haven't convinced you, open publications get more citations, they get more media attention, and there's more research funding nowadays for researchers working openly as well. It's the same for articles that have open data and open code, they also get more citations. And you've probably also heard of DORA, the Declaration of Research Assessment. It actually recommends that institutions stop using all journal level metrics, including journal impact factors, which we all so much rely on, so stop using it to evaluate research for promotion and for tenure decisions, and instead focus on research content, which I think is absolutely wonderful. On top of that, a number of journals have started to offer open science badges to signal and reward when underlying data, materials, or pre-registrations are available. And super recently, Bristol University actually started including open science in promotion criteria for their staff, which is an absolutely wonderful thing to do. And I think more universities are going to start doing that in the future as well. So, why do we need open science? Samuel Westwood did a great talk last week about the reproducibility crisis. He provided an introduction to most of the issues that can affect the research process. So, for the rest of this talk, I'll try and suggest some of the practical ways to address these issues. So, the first step in the research process is the literature review, which we often don't think about in the context of open science. So, if you look at the image on the right, the graph on the right, it shows papers that address the belief that beta amyloid is produced by the skeletal muscle of patients with a certain disorder. Don't have to worry about any of that. What you do have to see is that the 5 papers with positive results were heavily cited, while the 6 papers with negative results were not. There's only one citation, and that one is a critical one. So this means, why is that important? It's because without doing a systematic review of literature, you would come across a lot of findings supporting this claim, and you would probably not come across the findings that are being critical of it. So what would be the main consequences of not doing a lit review? Well, you can think of the fact that you could fail to build on previous research, waste resources, have issues with confirmation bias, and draw incorrect conclusions. And there's a really good paper called How Systematic Reviews Can Reduce Waste in Research, and I'd recommend reading that as well if you're interested. So, simple steps. Check if a systematic review has already been done, and if not, do one. It's actually not difficult. You have a lot of online guidelines on how to do it, and you could get a publication out of it, which is always great. So we got to the point of starting data collection. More often than not, our samples are too small, and we do not have sufficient power to detect the effects of interest. Then we might have flaws in our design, which we only see when we get to peer review, and I guess by then it's a bit too late to do anything about it. We move on and analyze our data. We're under a lot of pressure to get a p-value under 0.05. We may, play with our data or choose analysis methods that give us the desired result. And if we don't get, the magical value of p less than 0.05, we often end up putting our analysis in our file drawer. We'll come back to it later, or we won't. So when it comes to writing up, there's a huge issue with harking, which you might have heard of. It stands for hypothesizing after results are known. And Chris Chambers told a story about how some reviewers told authors that their results don't match their hypothesis. And they replied saying, in response to the reviewer's comments, we have now changed our hypothesis. And that really shocked me because I don't know how you feel about it, but I didn't really think that happens often. And clearly it does. So it's clearly something that we do need to keep in mind. So what can we do about all of this? Has anyone heard of pre-registration and registered reports? Yes? No? Okay, awesome. So I'll just very quickly go through it and explain the basics. So first of all, what part of a research study should remain beyond the scientist's control? Yeah, results? Okay, awesome. And what part of a research study do you think has the best impact on a scientist's career? Yeah, it's also results. So you can see where we might have a bit of an issue because there's a bit of a contradiction between what's best for science, which is high quality research regardless of outcome, and what's best for researchers, which is producing a lot of great results. I really like the graph on the left because it shows that the frequency of publication of results based on p-value, and you can see how this sharply drops at this wonderful magical value of 0.05. So, a possible solution to this issue. The idea of pre-registration is, well, it's simply, if you think of it as an online record of decisions around data collection and analysis that you make before your data collection. Meanwhile, the idea of registered reports is submitting your paper before data collection, going through peer review, and getting something that's called in-principle acceptance, which means that you can go ahead and collect your data, and on the condition that you don't deviate from the protocol, your paper will be accepted regardless of result. So it takes away this, incentive to get wonderful results. More than, I think, 200 journals now are accepting submissions as registered reports, and you can find a list at the link over there. There's also a great primer on this topic on the UKRN website, and I'm not saying it's great because I contributed to writing it, although that might be a bit of shameless self-promotion. But you can have a look at that, and you can also read about Hannah's experience publishing a registered report as part of her PhD. And she's now a lecturer at York, so clearly it worked out for her. I think while these are great, it's important to highlight that doing this doesn't work for everyone, particularly those who do very exploratory research. So for my research personally, I wouldn't be able to do this because I'm doing fetal MRI and it's all very exploratory. So this doesn't suit our work, but it works for a lot of other types of studies. Okay, so what else can you do? Well, you can make sure that your work is reproducible. You'll know that there's often insufficient detail in method sections to allow replication. I think a good example is the Journal of Psychological Science, which I came across recently because in their guidelines, they recommend reporting effect sizes and confidence intervals, and they do that to minimize problems associated with null hypothesis significance testing. They also required authors to disclose how many participants they excluded and why, and to confirm that all of their IVs, DVs, and conditions were reported in the methods, and this is regardless of whether they were included in the analysis or not. And the authors are also asked to specify how the sample size was determined. Also, I think you've all gone through this, I don't know, at least I have gone through this experience of, losing track of what you've done, and it happens quite a lot. So again, think of this idea that your most important collaborator is you in 6 months. And it can be difficult to keep track of what you did in Excel and SPSS. So I know that a lot of people use SPSS for their analysis, and I did until very recently. And I know the prospect of learning something like R can be terrifying. I only took the leap about 6 months ago, and although it's a bit of a steep learning curve, I think it's a lot easier than I expected. There are a lot of free resources out there, and I think a few of the ones I want to point out are the the Pirate's Guide to R, which is actually a really fun way to learn R. Also, the book by Daniel Navarro is absolutely wonderful, and R for Data Science as well, and obviously they're all freely available. I think the advantage of this is that the analysis takes the form of scripts. So you already have a full reproducible record of your analysis path that you can then share with your supervisors, your collaborators. And it's also a lot easier to keep track of what you've done and easier to redo the same thing over again if you need to on a different database. If you're not ready to take the leap yet, JASP and Jamovi are great alternatives because they look a bit like SPSS. And I know I don't use them personally, but I know for one of them you can also get the code for what you're doing and work reproducibly. Another way to contribute to reproducibility is also to improve your knowledge of stats. And there are some great free online courses by Daniel Lakens on Coursera that I would definitely recommend as well. So the first one I think is called Improving Your Statistical Inferences. So for those of you that are already familiar with R, I encourage you to look into R Markdown. I was weirdly scared of it until recently and realized it's actually not that difficult. The idea of it is that you can write your code and it transforms into a PDF or HTML or whatever output you want that you can then share with your supervisors or your collaborators and share it on GitHub, for example. And you can also have it as part of your supplementary material in a paper. And also, in case I haven't convinced you, R is also super fun and super nerdy. And it has some packages that allow you to make your graphs in the colors of Harry Potter and Game of Thrones or Lord of the Rings. And I don't know about you, but for me, that was a pretty big sell. to make the switch. Okay, so let's say that you've now done all of your research and are trying to get it published. How can you contribute to open science at this point? Well, you can try and publish null results, because what happens when you encounter the dreaded, p more than 0.05 value? Well, you could, collect more data until p drops under 0.05, and that is a very bad idea. And I don't think I realized how much of a bad idea it is until recently, when I was looking at Danielle Navarro's book, and she actually did a simulation and showed that for an n of 1000, if you peek at your data after every single observation, there's a 49% chance that you will make a type 1 error instead of the 5% chance that you're counting on. So that's terrifying. What else can you do? Well, you could try and publish a borderline significant result, which doesn't make sense in the frequentist approach. And I found this list of things that people, used in papers to express the idea of, borderline significant. I think my favorite is teetering on the brink of significance, or, just very slightly missed the significance level at 0.086. So yeah, don't do that. It's a bit of it's not the best idea. And you could obviously give up publishing this analysis. And I'd say always ask yourselves, had this p-value been significant, would I still have dismissed it as a flawed study? Would you still have, put it in your file drawer and never thought about it again? So obviously, what's left is to try and publish a null result. And I know that's difficult. I'm currently trying at the moment, and it's a bit of an uphill battle. I understand that, sometimes articles with null results may be held at a higher standard than those with published positive results. If you don't want to go through the effort of trying to get your null results published, or, maybe your PI doesn't agree with it, what you can do, which is still infinitely better than the file drawer, is to put your article on an online repository like, bioRxiv or OSF. I was thinking, I saw this tweet this morning from Daniel Lakens saying that one of his null results papers from OSF was downloaded more than 250 times. So clearly, there's a lot of interest for these things. And there's a list over there for journals that welcome null results. There are only a few of them, just so you have a rough idea. But obviously, you see they include things like PLOS ONE and Nature Human Behavior. So it's not just low impact, whatever that means, journals. And institutions have started to care about this too. I saw this article about Germany saying that scientists are now being rewarded for publishing null results. And lastly, ask yourselves, when coming to, choosing a journal, would you trust scientific journals that publish mixed results more or less than those that do not? If you think about what real research looks like. You can also share your data, obviously, if possible. And we've briefly mentioned the introduction of badges for open practices at Psychological Science, which has been associated with a steep increase in data sharing. And also briefly mentioned before that sharing detailed research data is associated with increased citation rate. So that's a good advantage for you guys as well. You can also make your paper available. You can publish open access if possible, and I know that's not available for everyone because of the high cost. But I think not a lot of people know about the fact that you can also make earlier versions of your manuscript available on a preprint server like bioRxiv. There's a good primer again on the UKRN website on open access, so you can have a look at that. And I think we're also starting to learn more about how journal impact factors are an inadequate measure of the quality or importance of research. On the left, you can see that there's a relationship between impact factor and number of retractions. And, we can only wonder why that is. And on the graph on the right, you can see that the impact factor on Nature is largely driven by a small number of publications rather than each individual publication having high impact. So we also know that the current system that we're doing right now of publish or perish is not working. We know that a very high percentage of PhD students develop a psychiatric condition, and apparently this rate is higher than for people working in defense and emergency services. And it's probably one of my favorite academia memes, because we're all juggling so much, between running experiments and writing manuscripts, and being unappreciated and not sleeping doesn't help either. So I think open research is trying to change the status quo and to ensure that the way we do research is better / not harmful anymore. These are some of my favorite papers on the topic that you can, if you want an introduction, you want to read a bit more on the topic. I did mention the UK Reproducibility Network and the primers that you can have a look at, and I think we're gonna work on developing some more in the future. And you can also look at the Open Science Framework as well. Some great people to follow as well if you use Twitter. Most of them are related to the UK Reproducibility Network. There's also an episode of, just shameless plug again, our podcast Postdocalypse, where we interviewed Sam about open science. And the schedule for the remaining talks, which will be, fingers crossed, if everything goes well, streamed at St. Thomas Hospital in the future. And I think just the messages to leave you with is that us scientists need to make reproducibility and transparency part of the research process rather than an add-on. And I'd say when you think of open research, just ask yourself, can I be satisfied in myself that I have tried as much as possible with what I have to be as open a researcher as possible? Thank you. Any questions?